All right, honors geometry. Here is the, going over quickly the answers to the Desmos activity. I redrew most of these. So let's go ahead and get to work. So we have a regular pentagon with a radius of 4. So 360 divided by 5 will give us our central angle. That should be 72. Take that and divide it by 2 to find this angle here, which is 36. Now we can use trigonometry to find our apothem. We'll call the apothem x, so I'll just write a for apothem. So I need to take the cosine of 36, right? Because we got a is the adjacent side, 4 is the hypotenuse. Cosine of 36 is equal to a over 4, which means 4 cosine 36 is equal to a, meaning my apothem is 3.23. And if I'm trying to find my 1/2 of a side, I'm going to take sine of 36 because I have the opposite and the hypotenuse. Sine of 36 is equal to 1/2 of a side over 4. So 1/2 of a side is equal to 4 sine 36. And so 4 sine 36 is 2.5 or 2.35. I'm going to go ahead and take that and multiply that by 2. And I get 4.7 is one side. One side is equal to 4.7. And if I want to continue, I will go ahead and find the area. So A is equal to 1/2 times the apothem, which was, 3.23. I'm using the exact value for my calculator, but I'm just putting down a rounded value. And then I need to take my side, 4.7, multiply that by the number of sides, which is 5. That gives me my perimeter. So I have 1/2 times my exact value, 3.23. I'm going up to my calculator, grab that value, times 4.7 times 5. I'm going to take that exact value from my calculator as well. Almost forgot. 4.7 times 5. And that gives me 38.04, or area is 38 units squared. All right, number 2. When we're given a regular, I believe this is an octagon. Yeah, it's an octagon, a regular octagon. And we are given that each side is 4. I like to fill in as much as I can from the beginning. So I'm going to go ahead and fill in the perimeter. So my perimeter is going to be 4 sides, or a 4-inch side times 8 sides is 32 sides. My area is 1/2 times the apothem times 32, which is my perimeter, right? 32. Now all I need to do is find my apothem. So I'm going to go ahead and draw a radii and apothem. That's a right angle. I know this is 2 because it's 1/2 of a side. All I need to do is find that central angle. So I'm going to take 360 divided by 8. I'm going to divide that number by 2. And I will get 22.5, which is that vertex angle for that right triangle we're going to work with, 22.5. So I need to use tangent to find my apothem here. So tangent of 22.5 is equal to 2 over x. That's opposite over adjacent. And that means 2 over tangent of 22.5 is x. That's my apothem. So 2 over tangent, 22.5 is 4.8, rounded. I'm going to take that 4.8 exact value from my calculator, multiply it by 1/2 and 32, and I get 77.3 approximately. 77.3 units squared, or inches squared, I should say. Inches squared. Okay. Next one, number 3. Find the area around the nearest tenth. So let's go ahead and draw my center and some radii from the beginning. Draw an apothem, perhaps. Right angle. I know that this is 4.5, so this is right just like the last one. A is equal to 1/2. My area is 1/2 times the apothem times the perimeter. We got 7 sides. 9 times 7 is 63. So my perimeter is 63. That's how I know this side is 1/2. And I know that central angle is 360 divided by 7 divided by 2 would be that vertex angle. And that's like 25.7-ish. So that guy right there is 25.7 degrees. Let's use some trigonometry to find our apothem. We got tangent of 25.7, exact value, I'll use that, equals 4.5 over x. So x is 4.5 over tangent of the exact value of 25.7. It's like 25.71428,571. So 4.5 divided by the answer is, I gotta take the tangent of that first. 4.5 divided by tangent of that 25 exact value is 9.3. So x is about 9.3. So put 9.3 there. I'm not going to round that to 9.3. I'm just going to take that exact value, multiply it by a half, and 63, and I get 294.3 units squared. Next one, number 4. This is just a 1/2 BC sine A question. So I'm going to go 4, 6, and sine of 45. 4, so that's 24 divided by 2 is 12, sine of 45, which is 8.48 or 8.5. All right, number 5, same thing, A equals 1/2 each of the sides, and then their included angle. So 70 divided by 2 is 35 here for n sine of 25. So 35 sine 25 is 14.8. Again, units squared. Number 6, I believe we need to find the area of the sector. So area of a sector is 70 over 360 times pi 12 squared. Make sure you're doing 12 squared and not 12 times 2, as some of us did today. 70 over 360 is about 0.19. And multiply that by pi. Oh, I know in terms of pi. So I'm going to go ahead and multiply that by 144 because that's what 12 squared is. And I get 28 pi units squared because it's an area. I need to go inches squared, though. Inches squared. Because it's an area, right? Number 7, I think we need to find the arc length for number 7. We do. So, arc length. Arc length, instead of using pi r squared, we're going to be using 2 pi r. So the fraction of the total degree, the measure of the arc, times 2 pi r. So 2 times pi times 12. So 24 pi. 24 times 45, I'm just multiplying across the top, dividing by 360, is 3 pi. How nice. That's in units, not units squared, because it's a length. Number 8, find the length of the arc in terms of pi and the digit round to the nearest tenth. I have a radius of 13. And what is it, 121? Pretend like that's 121 and pretend like that's a center. Find the area, oh, no, the length. Find the length of this arc right there. So we need to go length is equal to 121 over 360 again, right? Times 13 times 2 times pi. That would be r 2 pi, but it's all the same because multiplication is commutative, as I love to say. It applies in so many ways in multiplying fractions like we're doing in algebra. It applies in so many different places that the commutativity of multiplication comes in, and it shows you that you can do things a little bit different and get the same answer, which I think is cool. I didn't need to multiply by pi, did I? Oh, I should just take this and divide it by pi. I need it in terms of pi. 8.8 or 8.73-ish. So on 2 pi r, so I'll go with 8.7 round to the nearest tenth, right, pi. And that's in units. That's my answer. Next one. Find the area of the shaded section and round to the nearest tenth. Find the area of the shaded section and round to the nearest tenth. So we're going to go ahead and do that. That's right here. So the area of the shaded section is the area of the sector minus the area of the triangle. Okay, so the area of the sector is equal to, so I'm gonna write that, just this is the area of the shaded section. Let's start with the area of the sector. That would be 60 over 360 times pi r squared, so pi 6 squared. I'm gonna subtract from that the area of the triangle. I think the easiest way to do this is using our 1/2 BC sine A, but you can also do it using trig. So I'll do this one using 1/2 BC sine A, and they'll do the next one using trig. Both work. One's faster, but one is a good backup if you can't remember what the formula is if you're solving this on a test or a quiz or the final, whatever it is. So I'll go minus 1/2 times 6 times 6 times the sine of 60. So we will take 60 over 360 times pi times 36. We get 18.8-ish minus 1/2 times 6 times sine of 60. And that's like 15.5. So I'm going to take that 18.8 exact value, subtract it from 15.5, and I get 3.3 approximately. And that's in units squared, right? It's an area. Good. That's the shaded section there. The next shaded section one, we'll use trig to find the height of the triangle and figure out from there. We're going to start with finding the area of the sector, right? That's what we got to do first. Come on, move over. There you go. So the area of the sector, so the area of the shaded section is equal to, what's the area of the sector? The area of the sector is 74 over 360, right? That fraction of the angle times pi r squared, so pi 8 squared minus, here's the area of the triangle now. Area of the triangle is going to be 1/2 base times height, right? 1/2 times the base, don't know the base yet, times the height, don't know the height either yet, right? Okay, let's find the base of the triangle and let's find the height. In order to find the base and the height, we're going to have to draw an altitude, and since we know it's an isosceles triangle, that splits this into 37 and 37 degree angles. Then that means we also have a hypotenuse of 8, and we can go ahead and find the apothem there. That's the height. I'll make that h. It's not an apothem. Sorry. It's the height of that triangle. Apothem only occurs in regular polygons. That's a height, and then my base is just going to be that distance right there. That's going to be my base. I'll call it b. Okay. So my height. If I want to find my height, I need to use a trig function, right? I need to use the hypotenuse, which is 8, and my adjacent side, which is h. So cosine of 37 is equal to adjacent over hypotenuse. So 8 cosine 37 is my height. Oops, my height. My height is 8 cosine 37. My height is 6.38. So base times height. I'll write that there. I'll be multiplying that by my base. So I can find half of my base, right? This is 1/2 of my base right there. Let's go ahead and solve that. That's going to be opposite over hypotenuse. That's going to be sine of 37 is equal to 1/2 of my base times, not times, over 8. So 8 sine of 37 is equal to 1/2 of my base. So 8 sine of 37 is 4.8. I'm going to multiply that by 2 to get my whole base, and that's 9.6. Okay, so this whole multiplication down here, or this whole multiplication and subtraction up here is going to be my area. So I'm going to need 74 over 360 now, just typing everything in. That's just a number, times pi times 64. That is 41.3-ish. I need to subtract from that 1/2 times that 9.6 number. I'm going to grab that from my calculator, times that 6.38 number. And that is 30.76. I'm going to take that 41 number, subtract from it the 30.76 number, and I get 10.6-ish. And that's going to be in units squared. So that was using trig to find the height and the base and find the area of that triangle, this guy right there. You can also have done 1/2 8 times 8 times sine of 74. Either one. I think the 1/2 BC sine of A is faster, but I think that it's good to have a fallback of doing trig to find the area of those triangles. Number 11, find the angle. So in this one, we're given our arc length. So same equation, but instead of our missing being here, our unknown is the angle actually. So theta over 360 times 2 times pi times 5. So I'm going to go ahead and take this whole side and divide it by 10 pi. That's what 2 times 5 times pi is, right? So take this side, divide by 10 pi. So in my calculator, be careful how you type this. I'm going to write 12 and then divided by. Then I'm going to start a parenthesis and put 10 pi in the parentheses. So I'm doing 12 divided by 10 pi in parentheses. That way it does it 10 times the pi and then it divides the 12 by it. And I get 0.381 equals theta over 360, because these cancel. And I multiply by 360 on both sides. And I get theta is equal to, that'd be times 360, is 137.5. 137.5. And it says round to the nearest degree, so I'm going to go 138. That's degrees. Cool, 12. We're getting there, people. We're getting there. 12. Find the area of the shaded region. I would start by finding the area of the circle, and I would subtract from that the area of the regular hexagon. That's the way I would do it. You can also find an area of a sector, right? You could find an area of a sector, and then you could subtract the triangle and then multiply by 6. That would work too. There's many ways to do this kind of problem. So the area of the circle is pi r squared. So pi 8 squared, so 64 pi. I'm going to subtract from that the area of the regular hexagon. The area of the regular hexagon, I think these are not too bad to find because this is a 60-degree angle, meaning that I have a 30, 60, 90, right? Oops, didn't too far. 30, 60, 90 here. So this is a 30, this is my 60. So if this, which is the hypotenuse of that triangle, is 8, that means this side opposite the 30 is 4, and this is 4 root 3. So if I'm doing 1/2 AP, I'm doing 1/2 times my apothem, which is 4 root 3, which I just found, times the perimeter, which would be 8, right? Each side is 8, because if this is 4 and this is 4, that's 8. So 8 times 6 is 48. So 64 pi minus 1/2 times 4 root 3 times 48. That gives me 34.8. That's the area of the shaded region, units squared. I think that's a really fun one. You can also have done the sector and subtract the triangle, find that shaded region and multiply by 6. You could also do that. That may be faster for you. It just depends. 13. Yeah, I think this is a really fun question. So let's take a look at it. ABC is an equilateral triangle, meaning all these sides are the same. It's a regular polygon is what it's saying. So we're really going to be working with this right triangle, where this is 3. And since it's a triangle, I know that the central angle is 120, which means it's a 60-degree angle. This is a 30, and this is a 90. So if the 30 is opposite, or if the 3 feet is opposite the 30, the hypotenuse is 6 feet, which I didn't need to know. That's just the radius. And that makes the 60-degree angle 3 root 3 feet. That, in our terms of our picture, is right there. That's half of a side. So if I'm trying to find the area of this regular polygon, area of triangle, minus, for the shaded region, area of circle x2, right? Because I need 2 circles. So the area of the triangle would be 1/2 times the apothem, which is 3 here. They gave that to us. 1/2 times 3 times the perimeter, which is 3 root 3, and 3 root 3 again is half of a side, so the whole side right there is actually 6 root 3, which means my perimeter is 18 root 3, 6 root 3 times 3. Okay, I'm going to subtract from that the area of my circles. So I need to find the area of this guy. That's pi r squared, and I'm going to multiply that by 2. So 2 times pi times 1.5 is the radius squared. Running out of room on the side here. Squared. Okay, and the other set of parentheses to close it. So I'm putting my calculator as 1/2 times 3 times 18 root 3. And that's about 46.76. I'm going to subtract from that 2 times pi times 1.5 squared, which is about 14.1. I'm going to take that 46 number, I'm going to subtract it from the 14 number, and I get 32.6 units squared. Number 12, or number 13. So all I really need to do is do some quick calculations. It's not too bad. 14, looks like I need to find an area of a sector here. I need to find an area of a sector minus an area of a triangle there. So we're in good shape. We know our radius is 6. That's good to know. And we know that central angle there is 120, which makes this a 60-degree angle. That's a good thing to start with. So let's find the area of this guy first, just to get something out of the way. So the area of shaded is equal to, the area of that guy is 60 over 360 times 6 squared pi, right? R squared pi, or pi r squared. I'm going to add to that the area of the other thing, but for now I'm just going to leave that there. So 1/6 times 36 is 6 pi. So that area of that shaded region is 6 pi. Let's find the area of this other shaded region then. So let's find the area of the whole shaded region first, and then we'll subtract the other part. So the area of this whole shaded region is, or the whole sector, I should say, the area of this whole sector is 120 over 360 times 6 squared pi. So that would be like a third. So 36 divided by 3 is 12 pi. So 12 pi is my area of the sector minus, I need to find the area of this triangle right here. So I'm going to go ahead and do my 1/2 BC sine A. So 1/2 times 6 times 6 times the sine of, running out of room again, 120. Write it small. So I'm going to do 12 times pi in my calculator. And then I'm going to subtract from that, put in parentheses, 1/2 times 6 times 6 times sine of 120, end parenthesis. And that gives me 22.11. 22.11. And to finish, I'm going to be doing 6 pi. Did I say in terms of pi? No, I just said area of the shaded region. So I found the area of that one. That was 21.11. So 6 times pi minus that guy. What did I do wrong here? I must have done something wrong. 120 over 360 is 1/3 times 36. 36 divided by 3 is 12. Okay. And then 1/2 times 36 times sine of 120. I got to try that again. It's 1/2 BC sine A. Good. So I would take 12 pi, and I would subtract from that the 15 number. Gives me 22. Let's check our math down here. The area of the shaded there would be 6 over 360 times 6 squared pi. 1/6 is 6 pi. Oh, I subtracted. I need to add. There we go. So 6 pi, sorry about that, plus that number there is 41. There we go. Plus 22.11. Make sure you read your labels right. 41. That's the correct answer. 41 units squared. Or centimeters squared. Oops. All right, well, thanks for watching. Sorry about the mix-up there at the end, but hopefully that helps with your studying for the quiz tomorrow.